What's Geography Notebook? Do you want to try saying it?
Da, da, da.
One of the types of atmospheric optics that we enjoy and so many people appreciate, maybe more than any others, are going to be our beautiful sunsets. So let's talk a little bit about what's going on with those sunsets. We know that different things in the atmosphere are able to absorb light energy, but let's think about that light energy as it comes through. So here we are on the Earth, and the sun is high up there in the sky, and it's coming through. How much atmosphere does it really need to go through? Well, not all that much. It's a pretty thin layer that light energy from the sun is going to be going through, right? So it's coming and it's going to be going through this narrower part. And sure, the light energy will be absorbed by the oxygen and nitrogen. At least the blue rays are going to get bumped around. Not absorbed, just kind of bumped around a little bit there. And maybe there's going to be water particles or there's going to be salt or dust in the air, and that's going to cause a little bit of haze. We talked about that in another video. However, let's take a look. Let's assume that we're down here on the ground. I get a thinner pen. We are down here on the ground, and so during the day, we just have the sun coming through. But as that sun gets closer and closer to the horizon, as the Earth spins, and the sun is out there, and I know it's off in the distance, the sun obviously much bigger, but the sun is there. What are those sun rays needing to do now in order to reach my eye, right? Look at all of this atmosphere that the sun ray now needs to go through as it's coming through the atmosphere. Right? When the sun is 4 degrees above the horizon, the sun is up. Okay, so picture, if we can, a protractor. It's going to be 4 degrees up above the horizon. There's actually 12 times the amount of atmosphere that light energy needs to go through. So if you're going through 12 times the amount of atmosphere, sure, there's going to be a lot of diffusion going on, right? Not to cause any confusion. Diffusion, confusion. Okay, so this right here, much more atmosphere than what it is just between there and there. Okay, so what is happening as that sun does that? Well, there's going to be a few things that we have going on. First off, a lot of the shorter wavelengths have already been stripped away. So let's review really quick here. We're going to have, I don't need to pull out every different marker, but we're going to have red, orange, yellow, green, blue, and violet. And remembering that these are our longer wavelengths, these are our shorter wavelengths. Once you've gone through so much atmosphere, these guys over here have kind of been stripped away. Right? So all of your shorter wavelengths kind of stripped away already. Okay. Those guys we're not really seeing so much when the sun is lower on the horizon. So what does that leave us with? Well, we know yellow. That's what the sun, we usually associate the sun light with yellow because that's when we're actually able to see it, is when it's out on the horizon. Right? Oranges and reds. Right? Now, we also are going to have other small particles that are there in the atmosphere, and those guys are going to be messing with things as well. So if we have other particles, let's find a good color. Let's see if this pen will work. Other particulates. Those of you guys are usually, this is going to be a lot of the dusts, a lot of the salts, water droplets. All of those guys are going to be pulling away a lot of the yellows. Okay? This is going to pull away, or it's going to overly scatter. It isn't necessarily like grabbing it, but it's going to be scattered so much that once it's made it through so much, we can't really see a lot of the yellows, right? Unless we're looking straight at the sun. Right? But once that sun starts to set, then we start to see these different colors. Now, we're dealing with our oranges and our reds right now. Okay, and so what else do we have? We are going to have clouds that are going to be intermixed in with this, and those clouds maybe are grabbing other sun rays. They might be grabbing in some of the violets, the purples, the purples slash violets, or the blues. Usually not so many of the greens, but then a lot of the reds and the oranges come on through. Okay. Now, let's take a look at some pictures of this. This first picture is one that I took when I was up in upstate New York. And this is looking just after the sun had set, very close to Niagara Falls. Okay. Look at that sky. Okay, the clouds are messing with us a little bit. The humidity, or the water droplets that are floating around there in the air, both as accumulated as the clouds, and other ones that are just kind of a hazy cloud, right? So we see some clouds that are well organized and well put together, and those are going to be those purpley blotches that we see up there. But then we're going to have some of those lighter purples kind of up there on the left, and then that just glowing sun as we look across the river over into Canada. Okay? The glowing reds and oranges that are coming through. Another picture I want to show you. This one is a local one. This is just down here in southern Sacramento County. And you can see that the sun is kind of hiding behind there. Now, let's think about the, dare I say, the physics of the light. Okay? What do we have going on? Well, right there near the sun, right around the cloud, the light is almost looking white. Right? Because it's only being scattered by a small part of those clouds, but it's deeper than we think, right? Between us and the cloud is deeper between us and the sun. And so towards the middle, it looks very, very dark, and it's got almost that purpley color. At the top as well, there's not a lot of light hitting that cloud. And so that looks very dark, almost has those purpley colors to it. When we look at the other sky, we've got that brilliant orange and a little bit of reds coming in and around there. Okay? Coming back to our different light that's going to be coming through, we've got our reds and our oranges that really start to glow through. That picture that we had from Niagara Falls is like this beautiful sherbet color almost from the reds and the oranges. A little bit of yellows mixed in there. When we're looking at the local sunset that we had a lot of the clouds influencing even those oranges and those reds, right? So the oranges and the red light that comes through, these guys hit the clouds, and those clouds start to take on different colors as well. Okay. Now, one other thing that can have a huge impact on this is any other particulates that we have in the sky. If you're looking for beautiful sunsets, what you want to do is go someplace where there's been a forest fire, because we get a lot of small particles in the air from those forest fires, and those are going to be really scattering the longer wavelengths as well. One other picture I want to show you is this guy right here. This is a picture from Hawaii, actually. I'm kind of standing on the rim of a caldera out on the big island of Hawaii. And you can see a little bit of that smoke, if you will, coming up. It looks white there at the horizon, but as the light starts to interact with it a little bit higher, it almost has that red or orange color. And those are the particulates. Those are the aerosols or the pyroclastics coming up with the smoke out of this caldera. Okay? When we have those guys floating around in the sky, it makes for a really good, beautiful sunset. Okay? When we wake up and we have a sunset, that means that there's usually going to be particulates in the sky at that point. Okay? Now, if we have particulates in the sky in the morning when it's colder, usually means that we have a storm brewing. So you might have heard, red sky morning, sailors take warning. Red sky night, sailors delight. The red sky light means that we have that everything's working as we would expect, though. The warm air is rising, and we're seeing beautiful sunsets. Not necessarily an indicator of a storm. When we start to see the sunsets in the morning, that either means that we've got a fire brewing. Here in the Central Valley, if we have any fires up in the foothills, we'll often see really spectacular sunrises. Or it could mean that we've got a lot more water up in the atmosphere, water droplets starting to form, and that's going to be indicating that a storm is a brewing.